Our next speaker for this next section is Kaivan Kamali from Penn State University, and he's going to be talking about iRODS object store on Galaxy server, application of iRODS to a real-time multi-user system.
Thank you. Okay, so this is the outline of my talk. First, I'm going to give a brief introduction on what Galaxy is. Then I'm going to talk about how we integrated iRODS into Galaxy. And finally, I'm going to talk about some future work. So Galaxy is an open source platform for data analysis that enables users to use tools from various domains using a graphical user interface, run code in interactive environments like RStudio or Jupyter, and manage data by sharing and publishing the results, workflows, and visualizations. It also ensures reproducibility by capturing the necessary information to repeat every step in a data analysis. So why use Galaxy? Because it allows for accessible, reproducible, and transparent research. Because it's a graphical user interface based platform, researchers don't need any programming experience to use it. And also it allows for reproducible research, which is a main problem. A lot of results cannot be reproduced. However, Galaxy captures all of the steps in the analysis. And and all of the steps in the analysis, and also the parameters, the version of the tool that's being run, the environment that the tool ran in. So all of these are captured, and this allows the analysis to be reproduced. Finally, transparency. You can share your results with other Galaxy users, whether it's a data set, history analysis, or workflow. So that allows for transparency. This is a user interface for Galaxy. On the right-hand side, you have the analysis history. Every step in the analysis is captured. On the left-hand side, you have tools. There's a search box that allows you to search for tools. And in the center pane, you could enter the parameters for a tool or view the outcome. So Galaxy is available as a free public web-based platform supported by the Galaxy project. It can be also downloaded as an open source software and customized. Different groups have different needs, and they need to configure the Galaxy in different ways as they wish. Some organizations also have opened up the Galaxy server to the public, and those can be used as well. One important aspect of Galaxy is the Galaxy Toolshed, which is like an app store. Tool developers can push their tools to the Toolshed, and the Galaxy admins, which want to install tools on the Galaxy Index, will pull the tools from the Toolshed. And there are 3 steps to get your tool into Galaxy. You have to develop a Conda package, which is basically de facto standard for environment and package management. Then you write a wrapper, which is an XML document, formally specifies the input and output to your tool. And finally, it requests do a pull request for that XML wrapper to be included, and that deploys the tool automatically. One nice thing about the XML wrapper is, as you specify the input and output, the user interface for Galaxy will be automatically generated based on the input and output that you've specified. So that comes for free. This is an example of a tool wrapper. I think it's called a SeekTK. For example, here we're using version 1.2. The command specifies the command that is being executed. Input and output specify the input and output parameters, names, and types. And you can also fill out the help section with some help information if needed. You can also write tests for the tool here in this XML file and run it later as well. I've excluded those for brevity. So because a big part of Galaxy is the tools that are being used, we've streamlined the process of tool generation by this utility called Planemo. And it's a command line, a bunch of command line utilities. So instead of you creating XML from scratch, it basically generates the boilerplate XML code. So, you don't have to recreate XML documents. The utilities for linting, that if there's an error in your XML, will tell you. Also, you can use Planemo to run the tests in your XML and also serve them in a local instance locally. So there are three main Galaxy servers. One is United States one, Galaxy main. There's one in Europe and one in Australia, a bunch of smaller ones around the world. We have a major training network, over 300 contributors, over 300 tutorials, and 37 talks in the past 8 years. And there are tutorials for developers, scientists, or admins. And this is the architecture. So on the left-hand side is the TAC network, Texas Advanced Computing Center. And we have our web handlers and job handlers over there. And there's this space and the green at the bottom. But everything else is remote job execution via Pulsar, those are orange boxes, which is a remote job execution for Galaxy. And jobs are run on Johns Hopkins, Pittsburgh, other universities. Okay, so we've implemented Galaxy support, iRODS support for Galaxy, and most of the development was done last year, most of the heavy lifting. In the past year, we've done some modifications to the code and mostly testing and deployment. So Galaxy has this concept of object store, which basically is a data virtualization layer and allows you to store data on various backends. Backends is basically any persistence media that an object store can be configured to read from or write to. And Galaxy supports disk, S3, iRODS, among other backends. And usually, if you have multiple backends, you can come up with a data distribution strategy. So for example, you have a disk that's become full. Now you have a new disk. You don't want to move all the data from the old one to the new one. So you use something like a hierarchical data distribution in which you read from the first backend where the data exists, but you write to the first backend that way. Or you can have a distributed where the read is the same, but the writes are random. So the iRODS server for Galaxy is also hosted on the Texas Advanced Computing Center at the University of Texas at Austin. And we have two Galaxy servers, the test server and the main server. Both of them are configured to point to that iRODS server. The Galaxy code base is in Python, so we use the Python iRODS client code to interact with iRODS. And we specifically use version 0.9.0 and later, because along with the server version 4.29 and later, it allows for multi-threaded put and get. Because we wanted to get the performance of iCommands, and we work with iRODS team, especially Dan, to get this implemented. So we did a bunch of testing after those changes were made. We wrote scripts to upload files and download files from Galaxy with the iRODS backend. We measured the performance and all. We then switched a bunch of our internal users to use Galaxy with an iRODS backend. And finally, we contacted the power users of Galaxy. Like we sent an email to the top 50 users who run jobs extensively and asked them if they're willing to be beta testers for us, and they did that, and we switched them to iRODS, and we didn't observe any errors or performance issues. So it's basically in the prod right now. And this is the iRODS object store configuration in Galaxy. Most of the fields are pretty common: username, password, etc. Two of them that are important are refresh time and connection pool monitor interval, which I'll talk about. So the refresh time, basically in Python iRODS client and PRC, when you have a session, you have a connection pool. Connection pool has an idle set and then active set. So when you want a connection, First, you check the idle set. If it's something there, you pop it and you use it before that, you have to move it to the active set. So what we observed was that sometimes when you popped a connection from the idle set, we would get a network exception. We wanted to operate on that. And, this may be fixed by now with the changes that Dan introduced, but anyway, this was over a year ago. What we did was that we introduced this concept of refresh time. And if the connection that was popped from the idle set was more than refresh time seconds old, we would ignore it, destroy it, and create a new connection. So that solved the problem. This change was made in PRC. The other one, this is a change that we made in the Galaxy code, not in the iRODS code, but it's called something called connection pool monitor interval. So Galaxy has utilities that run periodic jobs. So they'll say they run every 8 hours or so. So before the worker thread runs, it's going to create an iRODS session, and we're going to have a connection pool with, again, connections in them. The job runs, and the next time it runs 8 hours later. And this 8-hour span, a connection is being kept in the idle set, which is stale already. And so what we did was we wrote added a new thread that would run every connection pool interval, monitor pool interval seconds. Let's say we set it to, I don't know, 5 minutes. This thread would check all the connection pools, and if there was any connection that would stale, it would destroy it. So in summary, we managed to integrate iRODS with Galaxy. And it seems like after Cyberse, it seems to be one of the major applications of iRODS to a real-time multi-user system. I don't have the exact stats about like how many users at the same time use Galaxy, but recently we reached 300,000 registered users. So the other thing is that we've thought about for fault tolerance and redundancy, we thought about adding a second iRODS server, maybe with a proxy in front of it. So the application just talks to the proxy, has no idea that there are multiple servers. And this is for fault tolerance and load balancing. We want to investigate that. And finally, we're interested in using iRODS storage tiering. I believe there's a plugin for that to move objects between slow and faster tiers, because we don't want, if the data hasn't been touched for months or years, we don't want to keep it in the fastest storage. We want that to be available to users who's using their data files at the time. So these are some of the, future work that we plan to do. So just wanted to thank the iRODS team. I'm a regular customer. Ask a lot of questions, and they're always very helpful. And these are some of the references. Thank you.
All right, thank you, Kaivan. Any questions? We have a mic right here.
Hey, thanks for the explanation. So of course I know that in Galaxy you can define workflows. So as a user you can go and say I want this and that to happen. What does it change from the user's perspective to use iRODS instead of whatever they were using before?
I don't think they would even know. There's no change. Yeah. Completely transparent. That object store layer basically abstracts away what storage backend you're using, so they don't see any difference. Yeah.
And if I may then, would you consider a possibility of including some metadata handling through that interface or another, so that you can actually exercise research data management from your compute time as well?
We could. I don't think we're doing it right now, but I don't think it's too difficult to add that. Yeah. Thank you.
Question over here.
I would like to ask, how did you map your user accounts from Galaxy to iRODS if you deal with access to files which are not public for everybody?
Yeah, this there is a server account that every user transactions handled through that. So we don't have different basically folders for each user. There's just one, and files are basically sent there.
Because Galaxy is using single account to access those data repositories. Is it right?
Yes, yes, but as far as iRODS is concerned, there's only one account. We do the translation on who can access what. The app, Galaxy app.
Thank you. That's really nice and definitely impressive. Do you see the other iRODS installation, the Galaxy installations globally adopt some of what you've done for their implementation?
Say it again, sorry.
The iRODS work
Yes.
that you've done that's on public Galaxy,
Yes.
is that something that other groups are adopting for their own?
They can, I don't know about Germany or Australia's like plans. They're independent projects, even though we're all under the umbrella of Galaxy project. They're independent projects, but the code base is there, and if they want to use it, they can. They just need to set up a iRODS server and point to it, configure it to point to that. Yeah.
And the reason I asked that question is, broadly for the iRODS consortium, when you are trying to understand what your reach to the communities, Galaxy by far is one of the most amazing projects that I've seen that touches just about any life science person across any continent. So this is definitely great work by both teams. So congrats.
Thank you.
I can add something to this because the Flemish Bioinformatics Center in Flanders, that they manage the usegalaxy.be instance. They've been trying to connect this with our iRODS server. So I don't know the status right now, but they have been testing your implementation. So there.
Yeah, I think somebody from that team contacted me. I forgot the name, but
All the Hest.
yes.
Yeah, so I know at least from one case that they are testing the system.
And over the years, we've tried to gather people, get something started, and then one or two people do it and they disappear. And I think I'm glad to see this happen at Galaxy Main so that it's going to stick and other people can take that best practice. So I think this is a great progress.
Thank you.
All right. Thank you.